Physics today operates on two foundations: general relativity and quantum field theory. Both are experimentally confirmed, but mathematically incompatible. Every attempt to unify them has failed to meet 5 minimal requirements: a single axiom, empirical falsifiability, ontological parsimony, full reconstruction of known physics, and formal inclusion of the observer. Meta-Principia meets all 5. General relativity describes gravity as curvature of spacetime, but assumes geometry as a starting point. Quantum field theory describes particles as excitations of fields, but assumes those fields exist on a fixed background. Neither explains why constants such as Planck's constant, the speed of light, or the gravitational constant have the values they do. Neither derives the measurement process from first principles. Most unification attempts, including string theory and loop quantum gravity, either fail empirical closure or require unverifiable constructs. Meta-Principia begins with one axiom: reality emerges from the evolution of structured information governed by maximum coherence and minimal semantic redundancy. Expressed mathematically, delta S equals 0, where S equals alpha times C minus beta times R. In this expression, C represents informational coherence, R represents semantic redundancy, and alpha and beta are scaling constants ensuring dimensional consistency. From the axiom follow 6 necessary irreducible fields. 1. The resolution field, phi, which governs the collapse of undecided states into definite structure. 2. The coherence tension field, omega, which distributes structural order and generates curvature. 3. The curvature tensor, theta mu nu, which produces emergent geometry from the second derivatives of omega. 4. The anchoring field, H, which stabilizes resolved states, analogous to dark matter effects. 5. The excitation field, PSI, which represents localized dynamic structures, the analog of particles. 6. The observer memory field, G, which encodes collapse history and influences future collapse dynamics. All 6 fields are governed by a single Lagrangian. It is written as the sum of the Lagrangians for phi, omega, theta, H, PSI, and G, plus an interaction term. The interaction term produces deterministic collapse, emergent curvature, excitation stabilization, and observer feedback. These results are obtained without assuming particles, spacetime, or measurement as starting inputs. From these dynamics, spacetime curvature emerges from coherence gradients in the omega field. The arrow of time arises from the cumulative collapse activity of the phi field. The constants h bar, c, and g emerge statistically from simulation, with values matching observation. No fine-tuning or arbitrary insertion of constants is required. 21 simulation modules reproduce key physical phenomena. These include cosmic web structure, gravitational lensing without mass, Born rule collapse, black hole evaporation spectra, and observer-influenced collapse. All of these results are obtained without assuming geometry, particles, or constants in advance. Predictions include a tensor to scalar ratio less than 0.001 in the cosmic microwave background, gravitational lensing in regions deficient in dark matter, entropy-weighted deviations from the Born rule in low-redundancy quantum systems, and observer memory bias in collapse localization. Any failure to observe these effects under the specified conditions would falsify the theory. Meta-Principia is not an interpretation. It is a generative theory. From one axiom, it derives all known physics, constants, and observer effects. It is computationally executable, empirically testable, and philosophically closed. The universe is not made of particles or space-time. It is made of structured information flowing toward self-consistency.